Now we will transition to a mini case study. In the next handful of slides, we will step through an actual event that impacted portions of North Texas. We will first begin by taking a look at some of the expectations of the morning forecast. Now, it was a cool and crisp morning with strong return flow ahead of a cold front that was advancing across North Texas through the day. Now, this return flow allowed for increasing temperatures and low-level moisture. And while there is very high confidence in thunderstorms developing along the cold front late in the evening, the degree of moisture return was in question. And the most likely mode would be a line of storms. So the low confidence portion of the forecast would we see prefrontal storms developing. And that was tied to how much moisture return would make it back northward ahead of the front and the prefrontal trough. Now, around 6 p.m. on this day, low top convection developed just to the southwest of the DFW Metroplex. Initially, this activity struggled to organize. Despite sunset, strong low-level winds increased, and this allowed for greater storm organization as well as strengthening. There were a handful of storms that emerged after sunset, and we will focus on the storm that eventually rolled through portions of Tarrant and Dallas counties. Now, just after 8 p.m., we start to see some organization of a supercell thunderstorm across northern Tarrant County. The base reflectivity reveals a loosely defined hook echo with increased concavity in the reflectivity field. The storm relative velocity product reveals a region of greater velocities, suggesting better organization of the low-level mesocyclone. We do see some slight concavity in the differential reflectivity field, as well as an indication of increased size sorting as the smaller hydrometeors are transported away from the core with just the larger hydrometeors remaining. This size sorting implies increased low-level shear necessary for possible tornadogenesis. At 8:35 p.m., the storm relative velocity product shows another increase in low-level flow, indicating strengthening of the storm, and it is probable that this is in response to greater organization of the low-level mesocyclone. One could argue that we see this organization manifest in the differential reflectivity field as smaller hydrometeors continue to be ejected away from the larger hydrometeors with a greater arc of differential reflectivity values as denoted in the ellipsed area. This ZDR arc can be seen stretching from areas near Grapevine over toward Carrollton. Roughly 5 minutes later at 8:40 p.m., the storm structure becomes very organized throughout the depth of the storm from a radar reflectivity standpoint. Note the positioning of the square icon. At the 0.5 degree scan from the NWS radar in Fort Worth, we can see a well-defined inflow or weak echo region. If we tilt up through the 4 degree scan from the NWS Fort Worth radar, we note that this weak echo region is bounded aloft by the greater reflectivity values. Now, some of the key radar features that we've discussed previously are very evident when one takes a cross-section across our storm of interest. In the base reflectivity, we see the pronounced weak echo and bounded weak echo regions are apparent. Again, remember that this weak echo region and then the bounded weak echo region are a sign of a strong thunderstorm updraft. Greater differential reflectivity values above the freezing level, as annotated here, can be observed, again, also a hallmark of a strong updraft. Recall that we call this area of enhanced differential reflectivity values Above the freezing level, the ZDR column. If we take a look at our correlation coefficient, or CC, these depressed values above the freezing level indicate a mix of hydrometeors, likely supercooled water drops, as well as ice. So we know that our strong thunderstorm updraft has the potential to produce some hail. At 8:49 p.m., the storm starts to undergo another transformation as it splits. Note the two reflectivity and differential reflectivity cores. One is located near the community of Carrollton in northwestern Dallas County, and the other is located near Louisville in southeastern Denton County. There's a sharp gradient in the differential reflectivity radar field between slightly noisier values down here near Irving and University Park to the more consistently higher ZDR values located here across the Carrollton areas. Again, these higher ZDR fields indicate more oblate and larger hydrometeors. The noisier ZDR fields may indicate more in the way of inflow. Another thing to point out is that the forward flank downdraft is certainly becoming a lot more apparent here in the storm relative velocity imagery. And this will likely become the dominant forward flank downdraft in what will become the right moving supercell that moves through northern portions of Dallas County. Note the shift in the tight reflectivity northward at 8:53 from the FWS radar. So as I toggle back and forth, this is from the previous slide, the location of the reflectivity gradient, and here it is in the current slide. This can also be observed in the differential reflectivity field. We also see that the RFD has become a little bit more established in the storm relative velocity field. And the response is that we get a more pronounced differential radar reflectivity arc. So we see an increase in the FFD and perhaps some signs of even an RFD, with a more defined hook echo region as well as a more pronounced differential reflectivity arc. As mentioned way back in the beginning of the presentation, meteorologists like to look at multiple radar elevations to put together a three-dimensional model of the storm. At the 2.4 and 4 degree elevation angles, one can clearly see rotational velocity signatures. More than likely, we are seeing the mid-level mesocyclone intensify. If we take a look a little lower in altitude or at the lower elevation angles, we can get a better sense of the wind field at these lower levels. In this case, the low-level wind field is likely responding to what was ongoing at higher tilts. The increase in the RFD winds, as annotated by the arrows, point toward the bottom of the screen, but note the modest outbound velocities toward the dashed line, which is the edge of our weak echo region. We are starting to see hints of low-level convergence, and hopefully you can see, given the wind flow annotated here with the white arrows. At the 2.4 and 4 degree elevation angle just before 9 p.m., we see a very defined or well-defined couplet with very high outbounds and noteworthy inbounds. Down at the 0.5 and 1.3 degree elevation angles, our convergent pattern has become even more rotational, also yielding high confidence that a tornado is imminent or it's already ongoing.